Hi everyone. Today we're going to talk about the notes on proportional and non-proportional relationships. So you should be on PR2, and again you want to make sure you're copying down everything I copied down. First thing we're going to do is define a proportional relationship. So a proportional relationship, I'm just going to write that down, is a relationship between two quantities in which the ratio of one quantity to the other is equal. Now, remember, a ratio is a comparison. We write it as a fraction, so think equal fraction. On Friday, we did an activity looking at the giant tortoise. And when we looked at that, we found out that the tortoise maintained a constant speed. Again, because his speed was constant, that relationship between time and distance is proportional. Now, we're going to look at charts, just like we did when we did the giant tortoise. And the first chart we're going to look at is Alberto typing 45 words per minute. And I want to know, is this relationship between the number of words and the number of minutes a proportional relationship? Why or why not? Now, what I want you to do is just put an X and a Y and an Y and an X. So time is X, words, number of words is Y, and then rewrite it in that fraction as well. So when I write out my unit rate, because that's all this is actually going to be, is just finding unit rate, I'm going to put 45 over 1. Then if he types 45 words in 1 minute, that means he does 90 in 2. He does 135 in 3. He does 180 in 4. And then he does 225 in 5. Now, I just got those by multiplying 45 by 2, by 3, by 4, and by 5. So in doing that, I know that these ratios are equal. I also know that when I divide 90 by 2, I get 45, 135 by 3, 45, 180 by 4, 45, 225 by 5, 45. So they all equal 45 over 1. My common ratio is 45 over 1, and this is a proportional relationship. So this increased by 45 each time. So he did 45 words per minute and increased it 45 words. Now, the second one, the table is done for you. So let's take a look at this table. It shows the distance Allison drove on one day of her vacation, and I want to know, is there a relationship between distance and time, and is it proportional? So here again, let's just put this X and the Y there, and then Y over X on the fraction there. So she went 65 miles in 1 hour. Second hour, she just did 120, 195 the third, 220 the fourth, 300 the fifth. Now, as I start dividing to see if these are equal ratios, if I divide 120 by 2, 120 divided by 2 is actually 60. 195 divided by 3 is 65. 220 divided by 4 is 55. 300 divided by 5 is 60. I can see right away that this is not proportional. She did not maintain a constant speed throughout her entire trip. So she did not drive a constant speed. This is not proportional. And then it asks why or why not. Well, there could be a lot of reasons. It could be that there was traffic. It could be that the speed limit changed on the highway. So the speed limit changed. It could be maybe there was an accident and traffic slowed down. So there are a lot of reasons why her speed didn't stay the same, but the bottom line is it's not proportional. Okay, let's flip it over to the back and continue looking. The Vista Marina rents boats for $25 per hour. In addition to the rental fee, there is a $12 charge for fuel. Is the number of hours you can rent the boat proportional to the cost? Why or why not? Well, here again, put an X and a Y there, a Y and an X. Now, I know that there is a $12 fee, and then it's $25 per hour. So the first hour I have the $12 fee plus 25. Well, that's going to be $37. Now, the second hour, if I rent it for 2 hours, I only pay that $12 fee once. But I'm renting it for 2 hours, so that's $50 plus 12, which is $62 for 2 hours. And then, again, the $12 fee, 3 times 25 is $75. It will cost me $87. Set it up to find the unit rate. So I'm going to do 37 over 1, 62 over 2, 87 over 3. Well, as you start to divide, right away you can see 62 divided by 2 is 31. This is not proportional. It's not proportional because the ratios are not equal. It's not constant. So ratios are not equal. And it's not constant. Number 4, which situation represents a proportional relationship between the hours worked and the amount earned for Matt and Jane? Here again, just put that X and Y right there. This will begin to make a little bit more sense as we go through and work more with proportional relationships. So again, I need to do 12 divided by 1. Well, that's 12. 20 divided by 2 is 10. 31 divided by 3 is going to end up being a repeating decimal. So I already know right now that Matt's earnings are not proportional. And here again, remember that we're going to do Y over X or money over hours. So let's take a look at Jane's earnings. Well, 12 divided by 1 is 12. 24 divided by 2 is 12. 36 divided by 3 is 12. So Jane has the constant rate of pay, and she makes $12 per hour. That is not constant because it's not equal. They're not equal ratios. Number 5. Plant A is 18 inches tall after 1 week, 36 inches after 2, 56 inches after 3. And then plant B is 18 inches after 1 week, 36 after 2, 54 after 3. So if I take a look at plant A, and again, weeks are going to be my X because that's my denominator. 18 will be my Y. So 18 over 1, 36 over 2, 56 over 3. Well, as I start to go through and look at this, well, this is 18. That's 18, but this isn't. This is going to be 18.6 with the repeating bar over it. So plant A is not proportional. So let's take a look at plant B. Okay, so here again, 18 after week 1, 36 inches after week 2, 54 after week 3. Well, 18 divided by 1 is 18. 36 divided by 2 is 18. 54 divided by 3 is 18. this is a proportional relationship, and so plant B is proportional. Okay, again, constant rate of change. Now, number 6, to convert a temperature in degrees Celsius to degrees Fahrenheit, we're going to multiply the Celsius temperature by 9/5 and then add 32. And I need to know, is Celsius proportional to Fahrenheit? And first of all, we want to complete the table. So again, let's think of Celsius as my X, Fahrenheit as my Y, and then if I take my Celsius temperature and I multiply it by 9/5 and add 32, degrees Fahrenheit will be 32. If I take the 10 times 9/5, add 32, this is 50. And again, I'm just going through and solving this. This is how I'm getting these answers. I'm multiplying 9/5 times the Celsius, and then I'm just adding 32. So 20 times 9/5 plus 32 is 68. 30 times 9/5 plus 32 is 86. So now I want to see, is this a proportional relationship? I'm going to look first at, and I should be able to tell right away because these two should be 0 in a proportional relationship, and we'll get into that when we look at graphs. But let's take a look at 50 over 10, 68 over 20, 86 over 30. Well, if you look at that, this is 5, this is 3.4, and this is 2.86 with the repeating bar over 8.6. So, are they proportional? The answer is no, they're not proportional. It is not constant. So it is not proportional. Again, it's not constant. It has to simplify to the same number. So now, let's make a connection here. What you should have realized as we were going through and doing this is when you calculate the ratios between quantities in tables or problems, you are actually calculating the unit rate. That's all we did on all of these problems, is we calculated unit rate. Make sure you fill in your Google form. If you have any questions, bring them to class tomorrow.